One of the options in setting up a static route is to include in our static route statement IP route, the network or host we're trying to get to. One of the options is to include the exit interface. Why is that option there? When should we use it? Those are the mysteries that we're going to solve right now in this video. So let's sync up and make sure we're on the same sheet of music regarding basic IP route statement, static routes on the Cisco router. The syntax would be something like, let's go ahead and pick on R1. Imagine we want to give R1 a static route to get to the 192.168.1 network. We've done this previously in the videos as part of the skill. The syntax would be something like this: IP in configuration mode, IP space route space the network we want to try to reach, 192.168.1.0 with a 24-bit mask. And then what we've done up to this point is we put the next hop address. And from R1's perspective, that next hop could be 10.12.0.2, R2's address. So I'll add that, 10.12.0.2. Or it could be over the serial link. It could be the next hop of the serial interface of R3, which is 10.13. This is the 13 network. 10.13.0.3. So we could have that. Alternatively, we could have 10.13.0.3. And here's why I want to introduce you to also including an outbound interface as part of our static route command. And here's where that could come into play. If we wanted to add that same static route on R1 to get to the 192.168.1 network, and we wanted to use this path between R1 and R3, the serial interface, we could do this. We could just say the exit interface is serial 3/1 and not include the IP address of the next hop at all. Now, this is an example of including the outbound or the egress or exit interface as part of our static route statement instead of the next hop address. And this is really most appropriate if we have a serial link or like a point-to-point link, because there's only two devices on that network. There's R1, there's R3, and that's it. So by specifying we want the exit interface to be serial 3/1, it's going to route the packet over that link, and R3 is going to get it, and it's R3's problem to think about how to forward that on the way to its destination. Now, the question that might come up is, well, can we use that same logic if we want this router to route out of its gigabit 1/0 interface? Could we say gig 1/0 and not put the next hop address? And the answer is, it is possible technically to do that. The syntax on the iOS router, it'll let you do it, but it's a really bad idea on Ethernet. Because if a packet comes into router 1 and they're in the routing table, the Cisco router says, oh, to get to 192.168.1.0, my exit interface is gig 1/0, and it doesn't know anything about who the next hop is, it makes the router do something really, really weird. And that weird thing is it makes the router ARP. It makes it ARP on this interface, and it'll ARP for the destination. So R1 is going to send out an ARP request on this network segment saying, hey, I'm looking for the IP address of some remote IP address. And then if this router right here has a feature called proxy ARP enabled, this router will hear that ARP request, and if it sees that it has a route for it, it'll respond to that ARP request with its own layer 2 address, and that will cause the router to be able to forward it over here to the next hop. This is what you call not optimal. So when we're doing static routes on Ethernet, we want to include the next hop, just like this one right here, every time. Now, there may be a case where the router has 2 or 3 paths to get to this next hop, and if you do want to force it out a certain interface for a certain route, we could do this. We could say IP route to get to 192.168.1.0 with a 24-bit mask. Go ahead and use gig 1/0 and include the next hop of 10.12.0.2 so that it'll know exactly who the next hop is, and it'll also know which, if you have multiple possible interfaces, which interface it should use to send that packet to that next hop. So in summary, if you're setting up a static route where the next hop is over Ethernet, if you're going to include the exit interface, that's fine, but you also definitely want to include the next hop IP address. And one of the primary examples of when it's okay to just put the exit interface without a next hop is if you have a point-to-point link, and that's being used for the static route. So here's what I propose that we do in the lab, just to reinforce the idea that we can include an exit interface. Let's use the serial link that's connected to R1 and create a new static route that says, to get to the exact IP address of 192.168.1.3, that would be a host route with a 32-bit mask, go ahead and use the exit interface of interface serial 3/1, and we don't have to put a next hop on it because it's a point-to-point serial link. So the syntax would look something like this on R1. We'd say IP route to get to 192.168.1.3. We're going to go specifically to the host address right there with a 32-bit mask. So we're creating a host route. We'll go ahead and simply say use interface serial 3/1 right here. So serial 3/1, press enter, and we're done. So let's go to the lab. We'll implement that route on router 1, and then we'll verify that it works. All right, so here we are on our administration PC, DC NUG. We'll open up MPutty in the upper left-hand corner. And let's open up a connection to R1. So here on R1, we'll do a show IP interface brief just to make sure what interfaces we have. So we have interface serial 3/1 with that IP address. It's up, fantastic. And let's do a show IP route. Always important to verify what we have in place before we start making changes. So currently we have a route to the 192.168.1 network, and what we're going to do is add a host route to 192.168.1.3, which is the gig 1/0 interface over on R3. And we'll tell it that the exit interface is serial 3/1 on this router. So we'll go to configuration mode, and here in configuration mode we'll do IP route space the 32-bit IP address of 192.168.1.3. We'll put in a 32-bit mask space, and then we'll do a question mark. So instead of specifying the next hop address, which we really should do if it was on Ethernet, because we're going over the serial link, here we can just say serial, and interface 3/1 is our interface. Press enter, and we're done. So if we do a show IP route, press enter. Now we have a 24-bit route to the 24-bit network, 192.168.1, going through Ethernet, and we also have this new longer route of 192.168.1.3, which is going to go out interface serial 3/1. And that's okay because it's a point-to-point link, and we don't really need to include the next hop address. So let's test it by doing a ping to 192.168.1.3. Now we have a network route to get to that network, and then we have a more specific host route. And to verify that we're really taking the right exit interface and using the next hop of 10.13.0.3, which is the serial interface over on R3, let's go ahead and let's do a trace. That'll help verify we're taking the right path. So we'll trace to 192.168.1.3, press enter, and sure enough, this says our next hop is .3, which implies it's taking that serial link that's directly connecting R1 and R3. In this video, we reinforced that if we're doing a static route over an Ethernet network, we want to include the next hop address. We could include the interface, the exit interface if we want to, but we also should include the next hop IP address. If we're connecting over serial interfaces, or we're setting up a route over a serial point-to-point link, we don't have to specify the next hop. We can just specify the exit interface. And that is the added information that I wanted to bring in as far as static routes go that I wanted to bring in this video. So thanks for joining me. I hope this has been informative for you, and I'd like to thank you for viewing.